Hi everyone, today I highlight on the CallTree widget, which landed in version 2.8 that was released in April, I think. And we wanted to showcase that widget through a couple of use cases to give you an inner sense of how it's supposed to be used, the kind of information it provides, and just how generally useful it gets when you're analyzing something in Reven. So that's the widget we have here, but before I'd like to show you what it's like without it. So there I'm at the start of my main function, and you see I have a couple of calls. I have a call to a underscore main, not very interesting, and I have something that it calls create file A, and using these debugger-like functions, I can easily skip over that. So that's my first function. Second, it calls printf, then it calls get process heap stub, and a couple of things. And what I'd like to have at that point is really just a general view of all the calls that main made during the life of the program. And the backtrace obviously doesn't give me that information straight away. I have to sort of reconstruct it. And probably at that point, a static view would help me with that. But what if there's a loop? I don't know how many calls were made. I don't know if I got into that basic block or something like that. And what I really want here is what calls that function made, and that's exactly what the call tree is going to give me. If we go here, well, that's what we have. It's really the list of calls that were made, but organized in a tree view. So you know that everything that appears here was made by this function, and that function itself was called by Timmy and by the main CRT startup. You see this actually represents the backtrace. Everything that's in bold here is present in the backtrace as well. So here it makes it easy to see every calls that were made, and I can explore more. And yeah, that's really the answer I was looking for. Everything that was called by main is here, and it makes the general process of what's going on very, very easy to read. And I can double click somewhere and get there and read the registers if I want to. Yeah, I can really use that as a tool to both get information and also to navigate. And you can finally also use it to explore the trace, because again, you can expand things, expand children, and look for something, and it tells you every time you change from one binary to the next. That's super explicit, so you can find maybe calls to external libraries or things like that. So that's really cool, and it helps you. If we go to the start of the trace, this is the very beginning of the program, and we start recording not at the main, but at the CRT main, really, which is the entry point of the binary. But for that use case, it makes it very easy for you to locate the main. I could search for the main function, but there, in just a couple of clicks, here it is. That's my main function, and I can just locate it. Now, again, I really want to emphasize on how important that widget is at giving you context and give you a general sense of what's going on. So if we switch over to another trace, here I'm just reading a buffer and I'm about to parse it, and I access that location, that moment in the trace, by just using the memory history and clicking at reads on that buffer. And the backtrace tells me that I am parsing XML, which is really important. But then it's hard to know at that point, for instance, what you're going to do with that XML that you just parsed. But if you just start exploring the function and you look at all the children, there isn't much, except when you start going to the try and finish call. And you see there are many, many calls made by that function. So if we start exploring towards the end, there's something here. There you go. And you see you starting to switch over from the XML library to the Jabber library. And that's really important. That's probably something like a callback or something like that that was made to be called when you find a certain marker in the XML file. And finally, if you start using it and you expand children and start building a very precise view of the process you're looking in, and then you start using other widgets like maybe the memory view, the memory history view, or searching for calls or something, and you find something interesting and you just locate it, then boom, it's really bad because you lost all the context that you wanted to see, especially here since I just switched process. But if we get to the previous call to that, yeah, I just lost everything that I just expanded, and really my view is reset and I don't like it. So what we can do there, we can just lock the call tree and start expanding and again building the view we wanted to see. Maybe we want to see one more parent call there, and we expand there and expand a couple. And since the view is locked, it's not going to reset anytime I navigate, but instead it will update that red line here that represents where I am in my trace. And from that, it's super easy for me to see that the calls to memcopy, which in my case is interesting, where is it in the trace? And if I expand that, you see that this is inside a call to that function, and we can expand, it will update, and there we find our call. So yeah, we feel that the call tree is a really good way of presenting the kind of dynamic information that Reven has, and is really a lifesaver when you start analyzing complex function. So thanks for watching. If you want to have more details about that widget, you can either get a look at the documentation for it, or back in April, we published the 2.8 announcement with some demonstration of the widget itself. And finally, if you look at the recent Chrome demo that we published, the version there has the call tree, so you can just experiment with it if you want. Thanks for watching.